Hello everyone and welcome back to UBAI. If you're interested in learning about reasoning agents and taking large language models to the next level, you're in the right place. My name is Malek Masousi and today we're building something super exciting, a reasoning agent capable of handling math and coding questions like a pro. Before we jump into the technical side, let's quickly understand how this approach can solve large language models' reasoning issues. As you know, vanilla large language models are great, but they can struggle with reasoning-intensive tasks like math. They might hallucinate, generate irrelevant answers, or fail to follow logical steps. That's because they're trained to generalize over a wide range of tasks, which limit their ability to excel in specific areas. If you're not familiar with what an AI agent is, it's simply a system capable of using external tools to perform tasks. In this video, we'll use the capabilities of agents to create a reasoning system that uses other AI models to reason and then applies that chain to answer user queries. The core idea is to fine-tune two smaller models on reasoning-specific datasets for a specific domain. These fine-tuned models will then be integrated as a tool, enabling a larger model to act as a smart agent that determines which model to use for a given query. With this idea, we achieve better accuracy, logical problem solving, and significantly fewer hallucinations. But how do we teach our smaller models to reason in a specific domain? All we have to do is use a chain of thought reasoning dataset. This is a popular method that trains the model to think out loud, breaking down problems into a step-by-step solution. I found two interesting datasets online that we'll be working with. The first model will be fine-tuned on math, using the Numina Math COT dataset. As for the second model, we'll be fine-tuning it for coding, using the COT code instruction dataset. Now that we know how our agentic reasoning approach will work, let's start coding. We begin with the first step. I've already covered the fine-tuning process in a previous tutorial, which I'll link for reference, but I'll quickly go over the key steps. First, we install the nsloth library to make the fine-tuning process simpler. We will load the smaller lemma models with 4-bit precision to reduce memory use while maintaining performance. To fine-tune the model, we'll use LoRa, which allows us to update only 1 to 10% of the model's parameters, saving time and resources. We will use predefined prompts to map the input and output of the dataset. Once the data is prepared, we can set up the trainer and start the fine-tuning process. We will use a standard training loop to fine-tune the model. After training, we'll save the model on Hugging Face for easy integration into our conversational agent. Before moving to the next part, make sure to run the first part to create as many models as you need. I only did 2 for proof of concept, but you can go wild and have fun with it. With our models ready, it's time to build the reasoning agent. Let's first understand how it's going to work. The agent receives a query from the user. It decides whether it's a math or coding question or unrelated to both domains. It calls the appropriate model to generate a reasoning chain. The agent uses the reasoning chain to make a response. All of this happens through something called function calling. Let's start building it. After calling our models, we define the tools that the AI agent will use. All we have to do is create helper functions for math and code queries that utilize the models to generate responses. We then develop the chatbot logic. We'll use Grok because it's very simple to implement. In the chatbot logic, all we're doing is prompting the model to pick tools when it needs them and providing a list of tools it has access to. The chatbot will now ask for the answers from the models when necessary. Let's see how everything works together. I'll say hello first. As you can see, it didn't call for help to answer this query. Next, let's ask a math-related question. The blue text is a reasoning chain generated by our math model, and the red text is the answer the chatbot made using the output. The same thing happens when we ask a coding question. Great, it looks like our chatbot works. If we compare the answers we just got to those of a vanilla model, we can see the reasoning agent outperforms the basic model. The vanilla model even made a mistake on the math question, proving how limited it can be. And that's it for today's tutorial. You now know how to fine-tune large language models for reasoning and using them to build an AI agent. If you enjoyed this video, don't forget to hit the like button and leave a comment down below.